All right, so again, we're just going to do a maximization or minimization of a problem, and we're just going to find the original solution. So we're just going to go through this as we would do it in a regular problem. So up here, we're going to make our A, and then we'll find A transpose. Well, A is 2, 1, 12, 3 minus 1, 3, and 40, 10, and then a 1. And, for the sake of doing all this, what does that equal? That's x1, x2. Now we're going to find A transpose. And so now 2, 1, 12, 3 minus 1, 3, and 40, 10, 1. So we just kind of rewrote each row as a column. And this is now y1, y2, at which point we can write our dual problem. So our dual problem now says we're going to maximize P equals, well, now we look at that bottom row. Now we have 12y1 plus 3y2, and it's subject to, and now we have 2y1 plus 3y2, and that's going to be less than or equal to 40. Remember, that starts out greater than, and we're converting it to less than. And then we have a y1 minus y2 is less than or equal to a 10. And y1 and y2 both have to be greater than or equal to 0. So that's our dual problem. We get that from A transpose. So we've done that. And now what we're going to do is we're going to write our E system by introducing the x1 and x2 variables. So now that becomes 2y1 plus 3y2 plus x1 equals 40, and y1 minus y2, and then plus x2 is equal to 10. And then we take this and take it over here, so it's going to be a minus 12y1 minus 3y2 plus p equals 0. And y1, y2, x1, x2 are all greater than or equal to 0. Now, we might be able to get our first tableau in here and do some work on it. So if we do, we're going to have y1, y2, x1, x2, oops, 2, then p, then we'll have a line. And this is x1, x2, p. All right, so we have what? A 2, a 3, a 1, a 0, a 0, and a 40. And then we have a 1, a minus 1, a 0, a 1, a 0, and a 10. And then we have a minus 12, a minus 3, a 0, a 1, and a 0. Okay. Now we have to do quotient rule. Which one is the biggest negative? Well, this one here is. That's the biggest. So we're going to take 40 divided by 2, and that's 20. And we'll take 10 divided by 1, which is 10. So that's the smallest. So that's going to be my pivot point. So that means that this is going to enter and this one is going to exit. Okay. Now that's a 1 already, so we just have to take minus 2 row 2 plus row 1, and that's going to be our new row 1. And we'll have to take 12 times row 2 plus row 3, and that's going to be my new row 3. Okay. All right, well, let's do that. And remember, it's going to be x1, then y1. So we're going to have x1, then y1, and then p. And then we have y1, y2, x1, x2, p. And then we have our line. We have that. And what row stayed the same? This one, so that's a 1. Yeah, it stayed the same. So 1 minus 1, 0, 1, 0, and then 10. And we took a minus 2 times that row plus that row, so we got 0. And we got 5. And then we got a 1. We got a minus 2, a 0, and a 20. And then we took a 12 times that row plus that row, so I got 0, minus 15, 0, 12, 1, 120. All right. Now, what one is the most negative down below here? Well, it happens to be that one. But notice this. This is a negative one. So this one can't work. So that has to be our pivot point just by default because we can't have a negative or a 0. And so that means we're going to take 1/5 row 1, and that's going to be our new row 1. And then if I take 1/5 1/5 row 1 plus row 2, that can be my new row 2. And if I take 3 times row 1 plus row 3, that could be my new row 3. So I didn't really do any quotients here just because that one's negative, so it can't be that, it has to be this one. All right, so now what we have to do is we have to do those calculations. And when we do that, this one, where's my pen here, up here, that enters, that one exits. So now I've got y2, y1, p. And so I have a 0, then I have a 1, I have a 1/5 minus 2/5, 0, and then a 4. And then I'm taking a fifth of that plus that, so that's going to be a 1, then a 0, and then a 1/5, and then a 3/5, and 0, and that's going to be 14. And then 3 times that row is going to be a 0, a 0, 3, 6, 1, and 120 plus that is going to be 180. All right. So now it looks like, guess what? Those are all positive, so we stop. Okay. So if we look at this problem, the max P is going to be equal to what? 180. And that's going to be let x1 and x2 equals 0, and y1 equals 14, y2 equals 4. Just going across. But what we want to do is we want to solve that original problem, the minimization. And so that says then min c equals 180 and x1 is equal to, now here remember this is x1, this is x2, so x1 is 3, x2 is 6. Now we're taking 3 and x2 equals 6. And so that is the actual solution to the original problem that they were asking for there. Okay. All right, so that one's done. So let's stop there and we'll come back for some more.